In the previous video, we explored what happens when we determine the slope of a line and use it to write the equation of a tangent line at a point of a curve. In this next example, we're going to explore what it means for the slope of a tangent line in more detail. So let's talk about the slope of a curve at a point. The slope of the curve y equals f of x at the point a comma f of a, where a comma f of a is just any x and y value, is the number m when the limit as h approaches 0 of f of a plus h minus f of a all divided by h. And a just represents the x value. The tangent line to the curve at the point P is the line through P with this slope. So again, all that means is that we're going to determine slope the same way we did before, but now we're going to determine it at an arbitrary value of x so we can plug in any x we want later. Again, a is representing a constant or any number. So in example 4, we're going to let f of x equal 1 over x. And for part A, we're going to determine the slope of the curve at x equals a. So recall that the limit as h approaches 0 of f of x plus h minus f of x all divided by h, this is going to give you the slope. But in this problem, we're going to let x equals a. So this is now going to become the limit as h approaches 0 of f of a plus h minus f of a, all divided by h. So now we're going to use our function, which is f of x equals 1 over x, and we get now that this is the limit as h approaches 0 of 1 over a plus h minus 1 over a, all divided by h. And this becomes very similar to the problems that we've done before. So we're going to go ahead and simplify everything by combining like terms. So this is the limit as h approaches 0. And I'm going to multiply this side by a divided by a. And I'm going to multiply this side by a plus h over a plus h, all divided by h. So this equals the limit as h approaches 0 of a minus a plus h, all divided by a times a plus h, all divided by h. So this is equal to the limit as h approaches 0 of a minus h divided by a times a plus h, all divided by h. So at this point, my a's are going to cancel off. And I'm also going to multiply by 1 over h over 1 over h. This is going to allow my other denominator to reduce off. And I get this is the limit as h approaches 0 of negative h divided by a times a plus h divided by h. These h's are going to reduce. So this is the limit as h approaches 0 of negative 1 a times a plus h. My h goes to 0 when I plug the limit in. And so this simply just becomes negative 1 over a squared. So now if I want to find the slope at any point, I can just plug in any value for a. So part B asks, where does the slope equal negative 1/4? So we want slope to equal negative 1/4, and we have our equation for slope is negative 1 over a squared. So since this is slope and this is slope, all we have to do is set the negative 1/4 equal to negative 1 over a squared. And so what I'm going to do here is I'm going to multiply both sides by the denominators. And so I'm going to get negative a squared is equal to negative 4. So a squared is equal to 4. So then a is plus or minus 2. So what I want to give here is a little explanation of what I'm talking about. So the explanation here is that the curve has a slope of -1/4 at the points, and now we're going to talk about how to find them. So if I want to know what the slope is when x equals +2, we take x equals 2, and f of x is 1/x, so then f of 2 is equal to 1/2. And if I want to know the slope at -2, I get f of -2 is equal to -1/2. So the curve has a slope of -1/4 at the points 2, 1/2 and -2, -1/2. So there are 2 points on this graph when the slope is equal to -1/4. So the last thing I want to talk about is what happens to the tangent line to the curve at the points a, 1/a for different values of a. So if we hone in on this graph and look at this for a while, you can see right now that the slope is -0.98. But if I were to draw a tangent line here, the slope is different than the slope here and the slope here. It's also different than the slope here and the slope here. So what we now need to do is describe the behavior of the slope. So we're going to break it down into pieces. So we have that m is equal to -1/a squared. So if m is equal to -1/a squared, we have that it's always negative. This is because whenever a value plug in, it's going to square it and then multiply by a negative. Also, as a approaches plus or minus infinity, m approaches 0. This means that the tangent line is becoming horizontal. As a approaches 0 from either direction, 0 from the right or 0 from the left, the tangent line gets increasingly steep. So as a approaches 0, m is approaching -infinity. So for the try example, what I want you to do is determine the slope of the line at any point x equals a, just like we did. And then I want you to describe the behavior of the slope for any value of a. So go ahead, pause the video, and give that a try. All right, let's work it out. So for part A, we're going to find slope. So m is equal to the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And in this case, we're letting x equal a. It's the limit as h approaches 0 of f of a plus h minus f of a, all over h. So now all we have to do is use our function to evaluate it. So this is going to be a plus h squared plus 2 minus a squared plus 2, all divided by h. So now I'll have to do some arithmetic. And so we get the answer is 2a. So for part B, what we're going to do is we're going to analyze the slope, and we're going to talk about what happens at different values. So what we're going to do first is we're going to look at a graph. So this is the graph of x squared, and this is the tangent line at the point 1. And as you can see, the slope is equal to 2. And so if we were to move this line, as x approaches infinity, this line is going to become steeper and steeper. As we approach 0, the line is going to become more horizontal, and even at one point become 0 and then become negative. So now what we're going to do is we're going to talk about that and we're going to write about it. So as a approaches 0 from either side, the right or the left, m approaches 0. So m is becoming increasingly horizontal. As a approaches infinity, m becomes increasingly vertical with a positive slope. And as a approaches negative infinity, m becomes increasingly vertical with a negative slope. So the key words here is that when it becomes 0, it becomes horizontal. When it becomes infinity, it becomes positive infinity with a positive slope. And when a approaches negative infinity, m becomes negative infinity because it has a negative slope because the line points down.